Okay, so today we're going to do a quick review on factoring, rationalizing, and synthetic division, which you're going to need for finding more complicated limits. So first off, factoring, you guys have been doing this since Algebra 1, but factoring, the first thing you always want to check for is a GCF. So is there a greatest common factor that you can factor out? Second, you want to see is there a special rule that applies. So one of them that you've learned in the past is difference of squares. And that is when you have a subtraction of two perfect squares. And that is an example of a squared minus b squared always factors to a plus b times a minus b. So that could be x squared minus 25. They're both perfect squares, so that's x plus 5, x minus 5. Okay, the next thing you could look for would be sum and difference of cubes. Now, I don't expect that you remember these formulas, but it's good now that they're back in your brain and you memorize them for this unit. So if you have two powers that are both perfect cubes and there's a subtraction sign in between, that's always going to factor to a minus b times a squared plus ab plus b squared. Okay? If it is a sum of two perfect cubes, okay, so a cubed plus b cubed, that will always factor to a plus b times a squared minus a times b plus b squared. Okay, so definitely start to commit those two to memory. You're going to use them a lot in the upcoming unit. So let's just look at a couple examples. If I gave you a problem like this, 5x squared minus 125, pause the video, see if you can factor this, see what you come up with. Okay, so your answer should have been, first, factor out a 5, that's your GCF. And then you have x squared minus 25 left behind. That is not fully factored. You can factor this further, which factors to 5 times x plus 5, x minus 5. Okay, the better you are at factoring, the easier some of these limit problems are going to be, so you definitely want to refresh on this. Let's look at one more example problem. If you saw x to the third minus 8, you need to recognize that 8 is a perfect cube, x squared is a perfect cube. So this is really x cubed minus 2 cubed. So using that equation that I showed you before, this is going to factor to a minus b times a squared plus ab plus b squared. Okay, now your a in this situation is x, and your b in this situation is 2. So this is going to factor to x minus 2, x squared plus 2x plus 4. Now the good thing, the second part will never factor further, so that's as far as you can go in a difference of cubes problem. Okay. Another type of factoring that we haven't looked at yet are trinomials. So this is what multiplies to the last and adds to the middle. It gets more complicated when your leading coefficient isn't 1, but in general, that's what you're looking at. So if you had this problem, 5x squared plus 20x plus 25. Now you could make your life a lot more complicated and factor it with a 5x and an x, but what you should recognize is that there's a GCF of 5. So factor out your 5 and you get x squared plus 4x plus 5. This is much easier to factor than before. So what multiplies to 5 and adds to 4 whoops, sorry, this is supposed to be a negative sign. Go back and make that a negative sign. So this should be minus 5. That makes more sense. Okay, so what multiplies to negative 5 and adds to 4? That's going to be x plus 5 and x minus 1. Okay, so that's just a quick review of trinomials. All right, so another important skill for solving limits is going to be rationalizing. So you're going to run into trouble in a situation like this. If you had the limit as x approaches 0, and the function was the square root of x plus 1 minus 1 over x. Well, if you just try to solve this algebraically and plug in 0, you would get the square root of 1 minus 1 over 0. Well, 0 divided by 0 causes an error, so that means there's something else you can do. What you need to do is to rationalize it. You guys have done this in the past. So what we want to do is get rid of the square root. So to rationalize, you're going to multiply by the conjugate. So if you don't remember what the conjugate is, let's start at just looking at the problem. So x plus 1 minus 1 over x. So to simplify this problem, we want to multiply by on the numerator and the denominator, you're going to want to multiply by the square root of x plus 1, and then you switch the sign, so now it's plus 1. And the square root of x plus 1, switch the sign, so it's plus 1. Now when you FOIL this, it's going to create a situation of perfect squares, and your center term cancels out. So in your numerator, first you do the first two terms. So the square root of x plus 1 times the square root of x plus 1 is just x plus 1. Then if you multiply your outer two values, you get plus the square root of x plus 1. And then if you multiply your inner two values, you get minus the square root of x plus 1. This should always happen if you rationalize correctly. Your center two terms should cancel out. They're exactly the same, but opposite signs. So we can just go ahead and cross those out. And then we just need to do our last, which is negative 1 times 1, so minus 1. Then in your denominator, for right now, you can just leave it as x times the square root of x plus 1 plus 1. Okay, looks a lot uglier than it is. If you go ahead and look in your numerator, your 1 and negative 1 are going to cancel each other out. So all you have left is x over x times the square root of x plus 1 plus 1. Okay, it gets even simpler now because you have an x in the numerator, x in the denominator, so they cancel each other out, and all you're left with is 1 over the square root of x plus 1 plus 1. Okay, so if we went back to that original problem where we wanted to find the limit as x approaches 0, you could now plug in 0 and you get 1 over, the square root of 0 plus 1 is just 1, so 1 plus 1. So that limit ends up being a half. Okay, so the next problem I'm going to give you, I want you to try this on your own. If you had a problem like this, the limit as x approaches 0 of the square root of x plus 4 minus 2 over x. So for right now, ignore the fact that we're doing a limit, and I just want you to try to rationalize this, because if you went in and plugged in 0 right now, you would get 0 over 0, which doesn't work. Okay, so go ahead and rationalize it, multiply by the conjugate, see what you get. So hit pause and then come back to check your answer. Okay, so what you should have started with doing was your original problem times your conjugate, which is x square root of x plus 4 plus 2 over square root of x plus 4 plus 2. Always going to be the same. You're just switching whatever sign is in between your square root and your whole number. Okay, in your numerator, when you FOIL it, the square root of x plus 4 times the square root of x plus 4 is just x plus 4. Your outer, when you multiply those, gets you a 2 times square root of x plus 4. And then when you multiply your inners, you get minus 2 square root of x plus 4. So they cancel each other out. So you don't even need to write it down. And then your last, you're going to get a minus 4. In your denominator, don't worry about multiplying it all out yet. You're just going to keep it as is. Okay, you'll see that your 4 and your negative 4 cancel out. And then also, once that's gone, all you have is x in the numerator and an x in the denominator. So we can go through, cross this out, and then we can cancel our x's. So all we're left with is 1 over the square root of x plus 4 plus 2. Now if we go back and look at our limit, which was as x approaches 0 of our original function, now we can plug it in. So we get 1 over the square root of 0 plus 4 plus 2. So that limit ends up being 1/4. And you can always check that by plugging it into the calculator. We're going to spend a lot more time on the limit side of things. I just wanted you to get a review of how to rationalize and use your conjugate. So the last thing you need a review of is synthetic division. Okay, now synthetic division only works when you have a linear divisor. So your divisor must be x plus or minus some value. Okay, so you have to be dividing by x plus or minus some value. So again, let's look at this limit problem. If you had limit as x approaches 2 of x cubed minus 8 over x squared. If you plug in 2, you get 8 minus 8 over 2, or sorry, not x minus 2, or not x squared, x minus 2 in your denominator. Then you get 2 minus 2 in your denominator, and now you have 0 divided by 0, which causes problems. So in order to solve this, one of you might have noticed that this is a difference of cubes up here, so you could have just used your difference of cubes and factored. But if you didn't pick up on that, your divisor is linear, so you can use synthetic division. So let's look at synthetic division. So if you had this situation of x to the third minus 8 over x minus 2. For synthetic division, you set up your box, your numerator goes up here, and you need to fill in any dummy columns necessary. So you write down your coefficient. So my coefficient of x to the third is 1. I don't have an x to the squared, so that's get 0. I don't have an x term, so that's a 0. And then I have negative 8 is my constant. You have to remember to fill in the columns that don't have a variable associated with it. Right? Then you take whatever you're dividing by and switch the sign. So since this is minus 2, I'm going to put a positive 2. Okay, now this is the steps that you need to remember. You bring down your first column. Then you multiply. So that's 1 times 2 is 2. And then you add, and you get 2. Okay, then you multiply. 2 times 2 is 4. You add, you get 4. Then you multiply. 4 times 2 is 8. You add, and you get 0. Now, once you get this answer down here, this is going to be your key. So the last number is always your remainder, and for right now, you always want that to be 0. Sorry, that's so sloppy. That's your remainder. And then this is your constant. Your constant, and then you just count up. So this is your x term, and this would be your x squared term. Okay, so that tells me that this problem, x cubed minus 8 divided by x minus 2, is x squared plus 2x plus 4. So that helps me because I know that if I divide by x minus 2 and get this value, I can multiply this by x minus 2 and get back to x cubed minus 8. So that allows me to factor my numerator to x minus 2 times what was left over. And then we still have the x minus 2 in your denominator. And now you see those cancel out. And now you can find the limit because you can plug in 2 and not run into any trouble. So go ahead and try this synthetic division problem. So pause it, give it a try, see what your answer is. Okay, so to set up your synthetic division problem, you need to take your numerator and write in any of your coefficients. So I have a 2 for the x to the third, I have 0 for x to the squared, -5 for x, and then -7 for my constant. Switch your sign on your divisor, so this becomes +2. Okay, then this comes down. You do 2 times 2 is 4. Add them, get 4. 4 times 2 is 8. Add them and get 3. And then multiply them and get 6. Okay, and then add them and you get -1. Okay, now this is going to be a problem because this tells you that it doesn't factor evenly. Okay, because there's a remainder. So if this scenario happens, that's not going to work for you. You're going to have to find another way to solve the limit. Okay, so the only time synthetic division is going to help you simplify and factor is if your remainder is 0. When you get a remainder of anything but 0, synthetic division isn't going to help you. Okay, so go back and watch what you need to again and bring questions to class tomorrow.